But this is going to be the year, guys. This is going to be the year. I know it. All right. So what is the limit and what is the notation? So this is the notation for limit, and L just means some number. And then how do we identify this X approaches C or X with an arrow C? You say that X is approaching C. And I wrote it down here. It says this reads the limit of the function F, so this is F, some function, as X approaches C is equal to L. And if you want to call the function F of X, that's fine. Then you can say the limit of F of X as X approaches C equals L. And that's all it is, guys. You also see a little sign. If you see a little sign on the upper right-hand corner, if you see a minus sign, that means from the left. So I guess let me circle that and put left or from left to not confuse that you're looking, right. And a little plus sign on the upper right-hand corner, that means from right. From right. So that's all we got to know, guys. And then I said the graph to the right here is f of x equals 2x squared plus 5x minus 3 over x squared minus 9. And notice that I have a little hole there. That's because if I were to expand this, so let's see if we can expand that. So the only way we can get 2x is 2x times x. And the only way we get a negative 3 is 1 times 3. So where does the 3 go? The 3 goes here and the 1 goes there because 2 times 3 is 6. So I want that to be positive. And then when I subtract 1, I get 5x. So there it is. That's my numerator. And on the bottom, the x squared minus 9 is the difference of squares. So it's x plus 3, x minus 3. So put that in somewhere, guys. If you haven't typed this out or printed it out, then don't worry. I'll record this and I'll upload this for you guys to see. All right. Notice that the x plus 3 cancels out, and I would have a hole. Where would the hole be located at? Well, the factor x plus 3, wherever x plus 3 equals 0. So it would be a hole at negative 3. And sure enough, at negative 3, you have your hole. Oh, by the way, guys, I can't see y'all's faces or hear anything. So if I'm going too fast or if you need clarification, just unmute the mic and then ask the question. That's probably going to be faster than typing it on the chat. So if you see anything, just go ahead and just unmute yourself and say it. And there's no, we're all family here. No one needs to get embarrassed. If you really want to send me a direct message privately, then that's fine. But we're all family. No one's gonna judge you here. No one judges here. So just ask me a question if something doesn't make sense. All right. So there's my hole. They found that the hole is at negative 376, and of course that makes sense. If you plug in a 3 into what's left, 2 times 3 is 6. 6 minus 1. Oh, hold on. What was canceling? X plus 3. Did I mess up? Oh yeah, 2 times negative 3. 2 times negative 3 is negative 6. Negative 6 minus 1 is negative 7. And then negative 3 minus negative 3 is negative 6. And then negative 7 divided by negative 6 is a positive 7, 6. So we're good, guys. All right. So I have this statement. So it says limit. They want to know as x. Oh, okay. What's up? Sorry. What's up? I didn't hear you guys. Oh, was that a typo or accidentally on mic? All right. As x approaches negative infinity, the graph of f of x, so let's see what that happens. As x approaches negative infinity, so that means as I approach negative numbers, this graph is approaching this horizontal asymptote. That y value is 2. And just type a 2, and there it is. And so how does this look in calculus limit notation? Like this, guys. Limit as x approaches negative infinity of this function f of x equals 2. And I'm going to change colors between red and black, between red and blue, so we know which one is which. I hope that made sense. As x approaches positive infinity, the graph of f of x approaches, well, as x approaches positive infinity, we're talking larger and larger x values. Where is the function going? Well, the function is going towards this horizontal asymptote, and that horizontal asymptote is again 2. So maybe I should have made 2 different graphs, 2 different horizontal asymptotes. That's fine. All right. How do I write it? Limit as x approaches infinity of this function equals 2. All right. We got another. Let me go back to red. As x approaches -3 from the left, the graph of f of x, okay. So if I approach -3 from the left, so I'm looking at the curve. If I'm approaching -3 from the left, the y value that I'm approaching is this y value, which happens to be 7, 6. So f of x is approaching 7, 6. Oh man, what the heck? Okay, how do I write it with limit notation? Limit as x approaches -3 of this function equals 7, 6. All right, let's go to the next one, guys. As x up, sorry. Some of you are screaming already, right? You're like, well, Travis, you said from the left. From the left. So we got to dictate it from the left. So put a little minus sign in the upper right-hand corner. So I'm sorry, guys. Yeah, you got to stop me. Stop me, guys. I did that one on purpose. No, I didn't. I actually just thought I just missed it. All right, as x approaches -3 from the right, the graph of f of x. Okay, I'm looking at this graph. If I approach -3 from the right, I'm approaching that same y value, 7, 6. So how do I write it? Limit as x approaches -3 from the right, 7, 6. Okay, so check it out. So this one says, I probably should, okay, don't worry. This one says +3. As x approaches +3 from the left, the graph of x approaches, all right. So here's +3. So if I approach f of x, did it say from the left or from the right? From the right. So if I approach 3 from the right, I approach positive infinity. So you can say positive infinity, this is the behavior, and positive infinity is the behavior, so you could also say does not exist. Both are correct. The infinity is behavior, and because the behavior is infinite, you could also say does not exist. So limit as x approaches 3 from the, oh man, I just did the right. Man, guys, you guys gotta fix me. I'm rusty here. It says here from the left, and I did the right, see? If I approach 3 from the left, you just gotta enter a negative so you don't have to erase. It's negative infinity. So just put a negative in the front. Negative infinity. If I approach 3 from the left, it's negative infinity. All right. As x approaches 3 from the right, the graph of f of x, that one, if I approach, here's the number 3, if I approach 3 from the right, if I approach the x value 3 from the right, the y value is infinite. So you can say infinite or does not exist. Limit as x approaches 3 from the right. All right. I was going to make a note. Well, I don't know if I should make the note right now. Okay, you know what? Let's talk about it. If these two here that I'm putting with that black bracket, if the limit from the left would not equal the limit from the right, so let me write it here. Side note. If, and I'm going to underline the word if, limit as x approaches -3 from the left does not equal limit as x approaches -3 from the right of that same function, f of x, then we say the limit does not exist. You can just say D and E. Now I saw the chat, so let me go to the chat real quick, guys. Okay, thank you. I'm glad the canvas finally worked. All right, so I hope that made sense, guys. If the limit from the left, notice that I have a little minus sign there, does not equal the limit from the right, notice a plus symbol on the upper right-hand corner. If they do not match, that's what that equal sign with a slash through it does mean, not equal. If they're not equal, then the limit does not exist. Notice here that the limits are equal. So I can write And sorry that all these notes are all jumbled up, guys. I'll do a better job on the next one, I promise. I can write limit as x approaches -3 of this function and say 7, 6, and that is a correct statement. And we're going to practice that in a little bit right now. All right. So that's what this is about right here. So on the next page, if you printed it out or are looking at it, on the next page I say, see, limit from the right and limit from the left. If limit from the right and limit from the left, they should have put those two first, by the way. Oh man, what the heck am I doing? I'm not resizing. There we go. If limit from the right equals limit from the left, then it just equals your limit. And that's all it means, guys. And we're about to practice right now. So look, let's practice. Let's wait for this to be nice and okay. So here's my graph. Here's my function. That's f of x to the left. And I have -1 from the right. So if you approach the x value of -1 from the right, well, that's the only direction you can approach anyways. If I approach -1 from the right, the y value is 1. So put a 1 there. Okay, I'm going to letter B, guys, the one on the right-hand side. This one, I'm approaching 1 from the left. So here's the x value 1. If you approach the x value 1 from the left, the y value you're approaching is 2. Who cares about the whole? It's just about where you're approaching. It's about where you're going. So now this one here, the x approaches 1 from the right. If I approach 1 from the right, that y value is a 1. All right. Someone tell me letter D. Be brave. It's okay if you're wrong. The limit as x approaches 1, and I don't have a superscript or I don't have anything in the top right-hand corner of a plus or a minus. What do you think that is? Unmute yourself and say it with confidence, even if you're wrong.
2?
Yeah, no what? So you're going to, what's another word for no? Well, I guess there's several words for no. It starts with letter D.
Does not.
Does not exist. Yeah, the Lindsay Lohan said it. The limit does not exist. D and E. Because they don't match. If I approach 1 from the left and I approach 1 from the right, they don't equal. All right, limit as I approach 2. Well, if I approach 2 from the left, it's 1. If I approach 2 from the right, it's 1. So this limit has to be 1. Limit as x approaches 3 from the left. Well, that's the only direction you can go. 3 from the left is just 1. Letter G. Letter G does not have the word limit, so this literally just means when x is 2, what is y? So where are you defined? When x is 2, the y value is 2. So this literally just wants that point, 2, 2. Because that's when x is 2, the y value is 2. And there it is, guys. See? This is easy. It's not even hard at all. All right. So Chavez, how's it going to look on Delta Math? Because we have Delta Math, and I want to know how it's going to look. Here's how it's going to look, guys. Matter of fact, you probably recognize the formatting. This function is from Delta Math. So here we go. Let's answer the questions. They want to know at 3. So limit as x approaches 3 from the left. So here's x equals 3. I look at the graph. If I approach 3 from the left, I'm approaching this hole at 1. So I put 1. Limit as x approaches 3 from the right. I'm looking at this graph. I'm approaching 3 from the right. It looks like I'm approaching this other hole, and that hole's at 3. The y value is at 3. I put 3. Limit as x approaches 3. Well, they don't match. Because they don't match, I'm going to write D and E. Does not exist. And then f of 3. Well, there is none. It's so you either do an empty set. This is actually an empty set. That means empty set. It does not mean 0, guys. It means empty set. It's like a blank. Non-existent would be the word. Non-existent. I don't remember if Delta Math uses the non-existent word, or it might say empty set, so you just push enter, which means just type in a blank. So that's empty set, not a 0. You know what? Let me put that in here because someone might confuse that for a 0. Not a 0. So that's how you say empty set in math, guys. That's how you say there's nothing instead of 0. All right, see, easy stuff. Let's do another one, guys. Let's say, use the graph of the function f of x shown below in order to determine all values of a for which limit I approach a is 0. Oh man, I should have given you these questions on delta math. I don't think I did. Okay, so all it wants to know, guys, is where is my limit 0? We're going backwards. So for what values of a, and a is just an x value. For what values of a is my limit 0? So focus on the x-axis. So where do I touch the x-axis or look like I'm approaching the x-axis? Because that's where the y value is 0. It looks like the first one, if I go left to right, because that's how you read a book, it looks like the first one happens at -5. You guys see that? So a is -5. So what does that mean? That means I can write this statement and it will be correct. Limit as x approaches -5, and this function is f of x, so I'm going to say f of x equals 0, and that's a true statement. All right, where else? It looks like right there at 2. So it looks like a equals +2, because it works from both sides, from the left and from the right. I'm converging at 0. So I'm going to write limit as x approaches 2 of that same function equals 0. So here's one answer. Here's another answer. There's 2 more answers, guys. There's 2 more answers.
I have a question.
Okay, ask.
Do we still put it even though it's a whole?
It's a whole. So if they were to say f of 2, you would say 1. F of 2 equals 1. But I'm asking for limit, and that's a difference. The word limit just means where are you approaching. You don't care if you're approaching a whole. If the function is does that make sense or no?
Yeah.
I think it's Viacana. I can't see.
Yeah.
Okay. I hope I never get any of y'all's names wrong while you're all talking to the mic. All right, here we go. So now we got to be careful, guys. So maybe I'll open up this quiz for maybe as homework, or maybe we'll work on it tomorrow. We'll see. So that's 7 there, guys. Here's how we're gonna write it. Well, I guess let's write the limit first. You already figured it out, by the way. Limit as x approaches 7, but you're not approaching from the right. You're approaching from what direction? Yeah, I'm waiting for one of you get from what side? From what side, guys?
The left.
Yeah, the left. So you put a little minus sign there of f of x, that would equal 0. So that means that a is 7, but I'll put a little symbol up there on the upper right-hand corner from the left. That's probably why I probably didn't assign it, because, let's see, determine all values. Okay, well, 7 is 1, but it's from the left. So I have to look at delta math to see how they did it. So maybe that's why I didn't assign it, because I have to look at that first. All right, there's one more. The 8 one there. A equals 8. Limit as x approaches 8 of that function equals 0. And there it is, guys. I don't know if delta math, if you would have just typed 7, if that would have worked, or if you had to do something special. But there it is. That's it. Okay. Don't worry, guys. We're almost done. We only have that, and it doesn't look like that much. Trust me, it's not that much. All right. So it says sketch a graph, and I have a whole bunch of stuff over here. And you're thinking, Chavez, I don't know how to do this. Yes, you do, guys. Maybe it's been a long time. Maybe it's because of spring break. You're all freaking out. But it's just a piecewise function. You just do it in pieces. And look, they're all linear. That's a straight line. 1's a straight line. It's a horizontal line. 2's a straight line. Another horizontal line. X minus 1's a linear line. Negative x plus 5. They're all linear lines. So since I know they're all linear lines, you're not going to have a hard time. And we don't have a calculator, guys, because we're stuck with Desmos and this right here. So let's see if we can do this without a calculator. So here's my grid. I'm going to draw 2 black lines. There's my grid. So how do you start? This is how you start. You know they're all straight lines. When x is 0, if I plug in a 0 in here, let's see, 0. Negative 0 plus 1. Well, there's no such thing as negative 0, but negative 0 plus 1 is 1. So 0, 1, put a point. That's 1. When x is 1, so let's see, negative 1 plus 1 is 0, so I'm going to say here's 1. So when x is 1, the y value is 0, but it's a hole, so make sure you put a hole like that. And then connect them. Connect these two. So there it is. I got my first one out. Check mark. All right. When x is 1, see, so now I'm looking at this. When x is equal to 1, the y value is 1. So this is 1, so I go 1, and I make a solid because there's an equal sign there. And I'm going to go all the way to 2, but at 2, you don't have an equal sign, so I'm going to put a hole. So 2, hole. Check mark, check mark. Oh, no, I haven't done that one yet. This one, when x is 2, the y value is 2. That's just a point. Point. So at 2, you go to 2 and go to 2, 2 and put a point. All right, let's go to the next one. I'm looking between 2 and 3, but 2 does not have an equal sign on the bottom, so let's see. 2 minus 1 is 1, so I'm back here at 2, 1, and then 3 minus 1 is 2, so I'm going to say here's 3, and then here's 2, and I'm going to make that a solid because there's an equal sign, and connect them. You still doing okay, guys? Okay. Last one here. At 3, negative 3 plus 5 is 2. So I'm up there, and it is a hole, but the other one is it covers it up. And then at 4, negative 4 plus 5 is 1. So I'm going to come right here to 1. I'm going to make that a solid because of the equal sign. And then bam, linear line. And there it is. I just finished. Now we're going to answer some. Oh, do we have any questions so far, guys?
Yeah, when you had for the first one of the last thing, there was a hole, but then there was a point. Do you just count?
Yeah, I know what you're talking about. You're talking about this one right here at 3, from this one and this one. At 3, 3 minus 1 was 2, so I had a solid. But then on this one down here, negative 3 plus 5 is 2, and it should have been open, but because the top equation was solid, you can't really tell. Does that make sense?
Yeah, okay. So you just kind of ignore it.
Yeah, well, you ignore it because at 3, the top equation, you ignore it because this equation right here that I'm putting an X on, it fills it in. So it looks like they both touch, well, kind of. Not technically they do not touch. But if I were to have an equal sign down here, they would both be continuous at 3. Like they touch, they connect. Does that make sense?
Okay.
Yeah, later on we're gonna say, are we continuous at 3? And then you would say, well, yeah, because there's no hole now. But we're not there yet. You're getting ahead of me. But yeah, does that make sense? Did I answer your question?
Yeah.
Okay, awesome. All right, let's answer these questions, guys. Oh, do we have any other questions, by the way? Okay, I'm assuming the silence is that we're good. Don't worry, we're almost done, guys. All we're doing today is I did an easy one on purpose. I think on last year's, this was like lesson 2 or lesson 3. But this time I just decided to make it notes 1. And I changed that, but I forgot to change all this stuff here. That's fine, guys. I hope no one's super upset that I didn't retype that. All right, limit as x approaches 0 from the right. If I approach 0 from the right, let me use a different color. I'm going to use green. If I approach 0 from the right, it looks like it is 1. So just put 1. So remember, those are x values that I'm looking at. As x approaches the 0 from the right. So that I approach the x value of 0, the y value is 1. All right, let's go to the next one. As I'm going left to right. As x approaches 1 from the left-hand side. So if I approach 1 from the left-hand side, as x approaches 1 from the left-hand side, the y value is approaching 0. You don't care that there's a hole. You just care of where you're going. All right, next one. X approaches 1 from the right. Well, here it is. Here's my function. If I approach 1 from the right, the y value is 1. Now go to the next row, or next row. Limit as x approaches 1. Well, from the left it's 0, from the right it's 1, so this one does not exist. Limit as x approaches 2 from the left. Well, if I approach 2 from the left, the y value is 1. See? Limit as x approaches 2 from the right. All right, let's see. If I approach 2 from the right, the limit is 1 again. The y value is 1. Limit as x approaches 2. Both of them match, so it's 1. That's the y value. As x approaches 2, the y value converges at 1. Limit as x approaches 3 from the left. If I approach 3 from the left, it's looking like I'm approaching the value of 2. Limit as x approaches 3 from the right. If I approach 3 from the right, I'm approaching the value of 2. So limit as x approaches 3, 2. Limit as x approaches 4 from the left. That's the only direction you can go. So if I approach 4 from the left, you're approaching 1. And then the last one, you don't see the word limit, it just says f of 2. So that means when x is 2, what is y? Well, when x is 2, the y value is 2. Boom. Done. And that's it. All right, so I think we got one left. Oh, okay. We don't have clickers right now. I guess we could have done a poll, darn it. Oh yeah, we can do it. Okay. All right, guys. This is gonna be fun. Try this one on your own, but send me the message through private. Send me the answer. So take 1 minute. Read this question and see if you guys can do it. Send me a DM, but private, what the answer is. It's okay if you get it wrong. No pressure, guys. All right, I'm gonna go ahead and start, guys. Most of you answered. I think there's only 1 or 2 that have not. Make sure you answer the question, because, we want to see participation. All right, so let's see. I'm gonna verbalize it first, guys. So, and then I'm gonna go ahead. I already know what you guys did. You guys probably tried to sketch this out, doing what we did a little earlier. That's fine. We're gonna do that in a little bit, but first I want to verbalize it. So let's see. As I approach 2, so let's approach it from both sides. Limit as x approaches 2 from the left-hand side of this function f of x. If I'm approaching 2 from the left-hand side, I have to use this one here in red that I'm circling. All right, if I approach 2 from the left-hand side, 2 squared is 4, 4 plus 1 is 5. I get 5. Now I'm going to approach it from the right. Limit as x approaches 2 from the right of that same function. Well, if I approach from the right, I have to use this one here that I'm circling in blue because those values are slightly larger than 2 for x. So if I approach from the right, it looks like I'm approaching 5. Notice, do they both match? I should use a neutral color here. Yes, they do. They both match. So because they both match, limit as x approaches 2 of this function is 5. Now, Chavez, how do I do it with a graph? All right, let me show you. So let me draw my grid. So here's my grid. And then here's what I would do. Between -2 and 2, I look like this parabola x squared plus 1. So x squared plus 1 looks like this. And then this one has a hole. This one's a solid. This one's a hole. And let's see, that's a 1 down here. And up here, that's a 5. Now between at x equals 2, y is 1. So I'm going to say here's 2, 2, 1. And then between 2 and 8, hole, hole. And it's 5 all the time. So there it is. So now let's look at it. With that graph, let's see if we can interpret. If I approach 2 from the left, I approach 5. If I approach 2 from the right, I approach 5 as well. So there it is, guys. You just have to go slow, and you can do it.